Hello, and welcome to the top 10 things you need to know for DBAs, developers, and managers. My name is Craig Mullins. I'm the president and principal consultant with Mullins Consulting, Inc., and it's my pleasure to present this iDoug session for everybody today. This was first delivered at iDoug in Orlando in April of 2013. What we'll talk about today is basically counting down the top 10 types of things that you need to know, at least in my opinion, whether you're a DBA, a developer, or a manager. We'll spend more time on DBAs and developers and a little bit on managers towards the end of the presentation. Now there's a boatload of information and details about DB2 for ZOS that are available and that probably would be good for everybody to know, but it's impossible to digest all of that. Instead, if you can focus on the things that are most important to you, instead of wading through thousands of pages of manuals and web pages and articles and presentations, that might be a more appropriate thing to do. So this session basically is going to take and distill down the essence of what you need to know into the top 10 most important things, again, in my opinion, for DBAs, developers, and managers. So we'll have 3 sections of this presentation, one for each of the categories I've talked about, and we'll talk about things that span the spectrum of items you might want to know, not just technology type of things, but career growth types of things. We'll look at performance and availability, ease of use, really across the spectrum, trying to narrow down what the most important things for you to focus on are. So without any further ado, let's start with the developers. And here we'll look at tips, techniques, tactics that will help application developers do their job more effectively and appropriately with DB2 for ZOS. Now, most of the things here that we're going to be talking about are going to be related to coding practices, but again, some are going to focus on other issues like communication, career management, and so. So starting at the top, master the basics. Essentially, that is understand how DB2 operates and how SQL works, and don't try to use DB2 the way you would use a non-relational, non-DBMS type of a system. A lot of developers come to DB2 from the flat file world, and they're used to master file processing and things like that. Instead, you really need to understand how DB2 is different, how it operates on sets of data. So the guidelines here on this slide, a bunch of you may have heard them already, but it can't hurt to repeat these things. Although simpler is better from a understanding and knowledge perspective, complex SQL is really going to perform the best. In other words, we want SQL to do the work, not the program. So instead of saying here's 3 or 4 simple SQL statements that are very easy to understand and taking the results and then trying to use them to drive other cursors, other SQL statements, it's better wherever we can to munge it all together. Yeah, that's a technical term, munge. Put it all together into one SQL statement and let DB2 figure out how to optimize that. Because if we do it in the program, we're probably not going to get it in the most efficient or effective way. And it's going to be less efficient because we're bringing the data into the program before we operate on it. Whereas if DB2 is optimizing it, then it can leave the data out in the database without having to bring it into the program before we determine whether or not we need the data. Corollaries to that are we only want to get the minimum number of rows we want and the minimum number of columns that we want. You don't really want any additional columns, any additional rows brought into the program. Sometimes people say that only the columns required thing is don't put select asterisk in your programs. And that's still good advice. Don't do that because that makes it difficult to modify the program, but from a performance perspective and a general rule perspective, it's only the columns we absolutely need should be there. So if we have 10 columns in the table and we only need 9 of them, list the 9 out. Every additional column that you request causes DB2 to do additional work. It's a little bit of work, but it's work nonetheless to bring that data from the DBMS into our application program. And if that SQL statement runs tens or hundreds or thousands of times a day, that's a little bit of overhead multiplied by tens or hundreds or thousands of times, and then that little overhead becomes a lot of overhead. Always provide join predicates. If we're taking multiple tables and joining them together, you want to make sure that in your where or your on clauses that you have a path from table 1 to 2, 2 to 3, or 1 to 3, 3 back to 2. There always needs to be this join criteria for all of the tables participating in the join. Failing to do that will cause you to have a Cartesian product. And what a Cartesian product is where you take all the rows in one table and add them together with all the rows in another table, and a lot of data with really no additional information, performance issues, and probably the wrong results. So what I'm saying here is you should not be causing DB2 to do a Cartesian product. However, if the optimizer decides that a Cartesian product is the right thing to do, then by all means that's fine, just so long as you're not forcing DB2 to do that. An example of where the optimizer may choose a Cartesian product would be in a big analytical data warehousing query where you've got a large fact table with hundreds of thousands or millions of rows in it, and smaller dimension tables being joined to that fact table, product, time, customer, and you're joining them all to a finance table maybe. And there's smaller amounts in the dimension table, large amounts in the fact table. DB2 may decide that even though there are no join criteria, to join 2 or 3 of the dimension tables together before joining it to the fact table to minimize the size of the intermediate result sets. And that can be a perfectly appropriate approach. So I'm not saying Cartesian products are always bad. What I'm saying is you should not be forcing DB2 to do them. Favor stage 1 and indexable predicates. A stage 1 predicate is evaluated earlier in the process. The earlier in the process you evaluate a predicate and can eliminate data, the more efficient the process is going to be. We'll take a look on the next slide at what that is, what's the difference between stage 1 and stage 2. And also you should favor indexable predicates. An indexable predicate is one where DB2 can use an index to satisfy it. Doesn't mean DB2 always will use an index, it means it can. A non-indexable predicate, on the other hand, can never use an index, so we want to try to avoid that. And I'm saying favor. I'm not saying avoid stage 2 and avoid non-indexable. I'm saying stage 1 is better, indexable is better. Also, the host variable data type and length should match the data type and length of the column where and when appropriate. In a couple releases ago, DB2 made it easier when the data types and lengths didn't match, as long as it's within the same data type family, like character 10 to character 15. It used to be that would immediately be degraded to stage 2, but that doesn't occur anymore. So what you should do when you go to a new version of DB2 is go to the performance guide and find the list of stage 1 and indexable predicates. For DB210, that's in the SC 192978 Managing Performance Guide, table 66 on page 269. Print that puppy out, give it to all your developers, and make sure that everyone understands what these predicates are, and say stage 1 better than 2, indexable better than non-indexable. We'll talk more about stage 1 and 2 in a moment. Okay, avoid table space scans for large tables. Usually, if you can get an index to narrow down the amount of data scanned, or if it's a partition table and you can only scan a single partition instead of the whole table space, these things are good because it limits the amount of data that needs to be scanned to get the data that you're looking for. Now I say usually because in some cases you may want to be producing a report of all of the data. Maybe it's a customer report and want all our customers on it. Well, in that case, scanning the table is probably the right thing to do. So it's not, very rarely do you have always or never in DB2. And the final thing here is sorting. Whenever possible, try to avoid sorting. Sorting is overhead. Sorting makes things go slower. Where you can, for your order bys and group bys, have indexes to support them. If DB2 has an index, try to use that index instead of doing a sort because it will be more efficient. Distinct. Only use distinct when you absolutely have to. What it is it will sort your results and remove duplicates. So if you say select distinct, column 1, column 2, column 3, DB2 is going to make sure there's no duplicates of column 1, column 2, column 3 in the results set. If you don't care whether there's duplicates or there never could be duplicates, don't use distinct. Sometimes where I see distinct happening is where people copy code and they copy it from one program where it made sense for the distinct to be there, and in the other program it doesn't make sense for it to be there. But it looks like it's working, so they don't remove the distinct and they don't know what it's doing there. You know, whenever you copy code, make sure that you know all of the constructs in the code you copied, and if you don't, look them up. Make sure you understand it before you use it in your program. And finally, from a sorting perspective, union all versus union. Union will sort to remove duplicates. Union all will not. It will allow duplicates to remain. So again, if you don't care about duplicates or there never could be duplicates, use union all versus union. So here's some high-level basic things that developers should know about SQL. We talked about stage 1 and stage 2, and I promise you I'd get back to that. Here's what the difference is. Whenever you go and request data from DB2, the data is sitting out on disk somewhere. The I/O goes through the buffer manager, and then the predicates get applied. At the data manager level, that's stage 1, and the data rows that can be evaluated at the data manager means that I can eliminate data that doesn't have to be moved on to relational data services, which is the next section of DB2 code. Now, these are just names for DB2 code where the SQL that you've written are going to be applied. So if all of our predicates are stage 1, then relational data services is real easy. It just sends it through and we get the result. However, if we have stage 2, then the relational data services will apply their predicates and eliminate additional data. So if we can eliminate more or all at the data manager level, then less data has to be moved from section to section of DB2. By limiting the amount of data that's moved from section to section, the more efficient our request becomes. So that's why stage 1 is better than stage 2. However, stage 2 is better than trying to bring it all back to the program and then eliminating it there. An additional basic, you've probably heard this, it depends. And that's the cardinal rule of relational database development, not just DB2, but for all relational database development. And it does depend. Most questions can be answered that way, but that's not a valid place to put a period. So what I'm saying is, when your local expert says something, you ask a question, they say something as it depends as the answer, and then turn around and they think they're done, that's not the end of the job. The answer needs to be it depends, and here's what it depends upon. So when someone answers it depends, and they don't say anything else, you say, on what? Give me more information. So the it depends rule applies and is valid, but it's not the end-all, be-all. It's let's figure out what it depends upon. And then the corollary to that rule here at the bottom of the slide is that hard and fast rules where you're trying to rigidly enforce something or rigidly forbid something is not a good idea. So simply stated, almost never say always or never. And even that corollary is flexible. We say almost never, not never say always or never. So keep those things in mind too, very basics. Number 2, understand the optimizer at a basic level. You should be able to look at this slide and explain to me what's going on. Anyone who's a developer. Basically, you've got the DB2 subsystem in the middle, and inside there, in the DBM1 address space, which is a component of DB2, lives the DB2 optimizer. And inside the DB2 optimizer are these query cost formulas that DB2 applies to your predicates to determine how to get the data. Okay? On the left-hand side are your SQL statements, the ones you've written to get data. That gets sucked into the optimizer, as well as information about your systems. How much memory do I have? What kind of processor am I running on? And statistics in the DB2 catalog. You need to run stats. If you don't run stats, there's some basic defaults out there that DB2 will use, but with defaults, you're going to get default performance, which is bad. So you want to be running stats so that DB2 has sufficient information to apply the query cost formulas appropriately. And then you may have a hint. And I'll talk briefly about that in a minute. So all this gets put into the optimizer, run through the formulas, and out the other end comes optimized access paths. DB2 has figured out how to get your data based on the information it pulls into the optimizer. Also, if we say explain yes, then there are a whole series of plan tables get populated, and that's the information that the DBAs and even developers can rely upon to say, what is DB2 doing? That's where the optimization decisions are stored in the plan tables. And Data Studio will use that information, or you can just go and query the plan tables yourself to see what the optimizer chose. Okay, that is something that anyone should be able to look at this slide if you're using DB2 and explain at a high level. Also, the optimization hint. Real quick, want to mention what that is. It's a way of saying, for this SQL statement, we don't want the optimizer to figure out a new access path for us. We want to try and use an old access path. Okay? We're not going to go into all the details of that right here. Basically, the other thing about the optimizer you need to keep in mind, and the whole point of this slide, is that it's not feasible for everyone who uses DB2 to understand all of the inner workings of the DB2 optimizer. There are a few people even at IBM who understand the inner workings of the optimizer. People like Terry Purcell. I mean, he works on it, he designs a lot of it, and can do as good a job as anyone on the planet at doing that. But not everyone can, because it's a very complex piece of software. So no one outside of IBM is fully going to understand every nuance of the optimizer. You can learn general rules. That's good. We can learn rules that say this preferred over this and this over this usually. But the biggest rule is to trust the optimizer to create the efficient access paths and to figure that he's going to do a better job, the optimizer that is, than a developer is going to do. And I apologize. I always make DB2 masculine. I say he for DB2. Stay with me. I apologize to my women listeners out there. So guidelines, do as much work as possible in the SQL, and DB2 code is more efficient than my code, more efficient than your code. Briefly touched upon the flat file master file processing earlier, but this is number 3. Unlearn that mentality when you're using DB2. You don't want master file processing. What that is, open up a cursor, do a fetch, use that to drive another cursor. Instead, when you're doing things like that, you should look for, oh, that looks like it should be a join. Joining is the way we use and access relational data, not open up a cursor, drive another cursor, open up another cursor, drive another cursor, like we used to do with reads to master files. The database is not a set of files. Files have no relationships that are set within and among them. Tables aren't files. They're based on sets, and are not ordered. So all the members of that set are of the same type. You can't guarantee that with a file. And when you perform an operation on a set, on a table, the action happens all at once to all the members of the set. So when you are accessing a select against a table, you are getting multiple rows, right? Rows aren't records. Records are sequential, one after the other, where the rows have no physical order. Yes, at some point they're physically stored on disk, but we're going to that data through the DBMS, and it has no concept of that physical order. And other things about columns, they're not fields. Columns are typed. Columns can be null. That's not the same for fields. So everything about the flat file, master file processing we did before DB2, and we still do with flat files, does not apply to DB2, so unlearn that. Also, we talked about stage 1 and 2, stages 3 and 4. You can build better programs by avoiding stages 3 and 4. We know what 1 and 2 is and where the processing is in the DB2. Earlier in the process at stage 1, later in the process at stage 2. Same thing with 3 and 4. 3 is even later than 2, 4 is even later than 3. Stage 3 is basically where we are moving predicates from SQL into the program. So instead of coding it in our where clauses, we bring the data to the program and filter it there. Bad move. Stage 4 is a black box. And you may not know what that is. What it really is a data access interface that application programs call instead of coding SQL inside of each program. When you do that, the programmer doesn't need to know SQL. Instead, all they need to know is the API call into the black box. The black box approach is called that because it acts like a black box. It shields developers from having to know SQL. When that black box is used, shortcuts get taken. Generally, if you're coding the black box, you're going to take all kinds of shortcuts and avoid all the basic rules we just talked about, or a lot of them. So you build, by design, poor performance into the black box, and that's bad news. Also, SQL is an access method to data. A black box is an access method to data. So you're putting an access method on top of an access method, and it's redundant, and there's additional path length for the code. Lots of reasons why black boxes are bad. If you want to dig into all those reasons, let me point you at the link at the bottom of this slide. That's an article that I wrote that's up on my website that'll talk through the reasons why I think black boxes are bad. And you can think of them as stage 4. Number 5, learn how to code nulls. Talked about nulls briefly, where a column can be nullable. What a null is the absence of a value. It's not the same thing as 0. It's not the same thing as an empty string. And it's not a null value. There is no value. It's the lack of a value. So that's one of my pet peeves about a lot of the documentation. It says null value in it. It really should just say null. Okay, so are you convinced it's different? Let me walk you through some examples. Termination date. Say there is a table of all employees at your shop where you work. What would you like your termination date to be set to? I don't know about you, but I'd want it to be set to null. I'd rather someone say, I don't know what his termination date is, than it's set to some valid date, even if it's way off in the future. Salary. What do you want your salary set to be? Null or 0? Well, neither really is the best answer there, but given a choice of only those two, I'll take null. I'd rather have my salary be unknown than, oh, I know what it is and it's 0. You ain't getting anything. Social Security number for a non-U.S. resident. You don't have a Social Security number, right? Hair color. What about hair color for bald men? Well, that might be an example of using null. Not really. In my preference, what I'd say is for that, where you have control over the domain, create a color called bald and go with that. Where you don't have control over the domain, like a date, like a number, in those cases, I think it's much better to use the null option than for where you have this control over the domain. And there's no real hard and fast rules. Now, all data types include the null value, the null indicator. It's distinct from all non-null values. It's a special value that denotes the absence of a value. So if we take a look at how we do this, it's a null indicator, and it's associated with the column. It's 1 byte. 0 or positive value means not null, whereas a negative value means that this column with which the indicator is associated with is null. So it's not stored in the column, it's associated with the column. And you have to explicitly deal with this in your programs if there is the possibility of a null. So if you look at the SQL on the right-hand side of the screen, we're selecting employee number and salary. Salary can be null. So we are coding it into salary and the salary indicator. Now, a common error that people do is they specify the indicator so the SQL works, but then they don't check the indicator and just use whatever value gets pumped into that column, which is basically garbage, whatever was there before, or low values, or whatever is stored in that particular area. So you shouldn't do that. When you have indicators, you should check them. If you don't specify an indicator for a nullable column, you get the -305 or the 22002 SQL state. So if you see a -305, it means you got a null and you didn't have a null indicator for it. When you code for null in your predicates, there's a special register, a special operator where you can say where salary is null. So at the top of the slide is correct. The bottom of the slide is incorrect. You can't say where salary equals null. Remember, a null is a lack of value. So no normal operators don't apply. You can't use greater than, less than, equal, not equal, less than or equal to, less than or greater than or equal. None of those work. You can use is null or is not null when you're checking for null. The other thing you need to keep in mind is there's some inconsistent treatment here. You just have to know how this works. When we compare values, any column, where column equals column, if they're both nullable and they're both currently null, that's not true. A null doesn't equal a null. That returns unknown. I don't know. I don't have the values. However, a null is equal to a null in terms of sort order. So all the nulls grouped together for order by and group by. Also, nulls are considered to be equal in certain situations. When duplicates are eliminated by select distinct or count distinct column, and in unique indexes if you don't have where not null specified in the index specification. So there's some inconsistency there, but it's not glaringly difficult to wade through it. I mean, would you really rather want a separate row for each null in your output when you're doing group by and order by? Yeah, probably not. A couple more things about null and we'll move on. Null divided by 0 is valid. I know a mathematician wouldn't like it, and there's no value that you could supply for null that would eventually make it not an error in math. But the ANSI standard says null divided by plus minus multiplied by anything is null. So null divided by 0 is null. Keep in mind that the functions average, count distinct, sum, max, and min will omit column occurrences that are set to null. So in other words, average of column A is not necessarily equal to sum of column A divided by the count asterisk. Sum of column A is summing up values stored in column A. Count asterisk is counting rows. You'd have to say count column A, not count asterisk. And also, finally, consider this equal at the bottom of the screen. Select sum of salary from employee where department number is greater than 999. For the purposes of this example, assume salary is defined as not null. So we can't have any nulls in the salary column. This query could return a null if there are no department numbers greater than 999. It doesn't return 0. It returns the empty set, the sum of which is null. So when you're using functions in these cases, you do need to specify a null indicator so that that select can tell you whether or not the result is a null. So be careful. This could work maybe instead of 999, we've got a host variable there. We keep putting different values in until eventually we put a value in that causes a null to be returned. And when the null's returned, there's no null indicator, which throws a -305. You say, but it's been working. Well, yeah, it's been working because you've been lucky, and now you got to go in and make the code right. Use the null indicator. Okay, number 6, avoid bachelor programming syndrome. And everyone knows what that is, right? It's fear of committing. Every program that modifies DB2 should implement a commit strategy. You only rarely should avoid issuing commits. Maybe it's a very small small program, runs very quickly, in and out. That might be fine. But even then, it's probably wise to clearly document in the program why there are no commits being issued. Otherwise, you should plan and implement a commit strategy. After so much time goes by, after so many modifications happen, we issue a commit. If you don't do this, then your system is going to start experience locking problems. And it probably will not be the program that is not committing that's causing the problem. That program is just going to greedily consume all the locks. And other programs trying to concurrently access the same data will not be able to get in because your program that didn't do any commits is holding the locks and not letting them go. So you, the perpetrator of the problem, not doing commits, are causing problems but still running, and everyone else who coded appropriately is starting to fail. So if you see a lot of lock timeouts, start looking for where the programs are that aren't issuing commits. A lot of times that's the problem. Some real quick commit guidelines. Your mileage may vary. I'm not going to go over this in any detail. Know the SQL tweaks. There's some shorthand tweaks that you can apply to SQL that helps to coerce or encourage the optimizer to make certain decisions. If you say optimize for one row, then you're saying I'm only retrieving a small amount of data. And it should also eliminate list prefetch. So this is a good idea sometimes for your online transactions where you don't want them out there doing all the list prefetch before it returns any data to the screen. There's the no ops. The plus 0 or minus 0, the divide by 1 or a multiply by 1, or appending an empty string. All of these are going to leave the results exactly the same, but it's going to make the arithmetic expression non-indexable. So what you can do is add the no-op where you do not want DB2 to choose an index. Maybe you want DB2 to choose a different index. Now, non-column expressions are indexable. That's as of version 5. But IBM's made an exception for these specific no-ops. So you can keep using them to say, don't use an index here, let's use it over here. Here's an example where we're concatenating an empty string in the last predicate. We're saying A01 concatenate empty string. And that will disable matching index access, but it'll leave the predicate stage 1. So what we're trying to do here is say don't use the work depth index, maybe come up and use the employee number index. Another type of SQL tweak, if you use a scalar function on a column, that makes the predicate non-indexable. So this can work like a no-op too, unless you've got an index on the expression. And that's since version 9 you can do index on expression. So here if you've got two indexes that exist, one on last name and one on salary, that's all that's there. And DB2 is choosing salary instead of last name, then we can say instead of salary greater than 5,000, we'll say where decimal salary, comma 7, comma 2 is greater than 5,000. Move that up here. DB2 won't choose the index on decimal salary 7.2 for the salary index, and we'll try and use the last name one instead. What about join order with tweaking? Maybe you want to influence DB2 to choose a different order for the tables that you're joining. Basically, we're trying to get the smallest number of rows that qualify. That should be the starting table. Oh, you can add more predicates, making the optimizer think that the number of rows that qualify is smaller. Or you might make the join predicate on table A non-indexable, like so. Okay, moving on, you need to understand dynamic versus static SQL. High level, dynamic is coded and embedded into the program differently than static. You don't hard code it necessarily, but you can build it on the fly as it executes. So if you need to do different statements based on different conditions, dynamic's the way to go. Once it's built, the statement has to be compiled using prepare, or an implicit prepare gets issued behind the scenes with the execute immediate flavor. So there's multiple flavors here, and you need to read up and learn on the different ways to use dynamic SQL. Static, on the other hand, is hard-coded and embedded in the program. It's bound into a package. You can't change the SQL inside the program, whereas with dynamic, you can build it on the fly. Static, you can't. So dynamic is more flexible than static. Static offers some flexibility using host variables, but not flexibility in terms of the composition of the statement. But it does offer the ability to know beforehand what access paths are going to be used when the program runs. So what criteria should you use to figure out when should I use dynamic, when should I use static? Well, look at the performance sensitivity of the statement. You'll have a higher initial cost per SQL statement with dynamic because you need to prepare the SQL before you use it. However, once it's prepared, that difference in execution time diminishes when you compare dynamic versus static. But that is an influencing factor. The uniformity of the data. Dynamic SQL can have more efficient access paths whenever data is not distributed uniformly, or whether it's correlated. Things like city, state, and zip code, they are correlated together. You won't have a zip code that's in Illinois also be a zip code that's in Pennsylvania, for example. Range predicates. You should favor dynamic the more you need to use ranges. Greater than, equal to, less than, equal to, greater than, less than, between, like. These are your range predicates. And the optimizer here can take advantage of the histogram stats and the distribution stats to possibly come up with a better access path because the actual range is known at dynamic time. Repetitious execution. The more the frequency of execution increases, the more you should favor static, or maybe dynamic with local dynamic statement caching. That's because the cost of the prepare becomes smaller as a percentage of the overall runtime of the statement as it runs more frequently, if indeed the cached prepare is actually reused. The nature of the query, when you need to build the statement at runtime, favor dynamic over static. In fact, you can't build it statically, so not favor, you have to use dynamic. The runtime environment, it can be the answer when you need to build an application where those database objects may not exist when you want to pre-compile your program. Dynamic might be a better option than static with validate run. And also the frequency of run stats. When your application needs to access data that changes very frequently and might even change dramatically from one period or point in time to another, you really should consider dynamic SQL instead of having to worry about rebinding your packages all the time. Number 9, multi-row fetch. Learn about it. What multi-row fetch is, instead of getting data a row at a time, you get it multiple rows at a time in a block. The program will get that array into an array in the program, and then they in the program have to navigate through that array, and then when you're done with that array, request an additional block be put into the array. So it's at a different, higher level, getting more pieces of data at once. Let's look at the high-level depictions of how this works. Now, traditionally, an application will execute an open cursor statement, and DB2 creates a temporary result set of requested data. Once that result set gets created, the application has to execute a fetch for each row of data in the result set. The number of fetch statements executed can be a few, to a few hundreds, to tens of thousands, or even millions with each fetch, and that's going to result in thousands of machine instructions. For batch applications that access a lot of rows, fetches that must be executed might be a rather resource-intensive process using this one row at a time fetch process. Now instead, here's an example with multi-row fetch. This was introduced in version 8, and it allows a fetch where you can say, here's the number of rows that should be returned from DB2 for each fetch statement. And what that'll do is it will reduce the number of calls and the amount of overhead. Now, you have to design your application to handle multiple rows. If you've got an application that was built for a single row fetch, rewriting the application to handle multi-row fetch it's not really a trivial task. It's going to require some amount of coding and testing, but it can return a significant performance gain. So we say, give me 10 rows, give me 10 rows, instead of give me 1 row, give me 1 row, give me 1 row. So we can fetch 20 rows with 2 fetches as opposed to 20 rows with 20 fetches using traditional DB2 fetching. So what are the benefits? It can greatly decrease the amount of CPU required because it reduces the movement of data across address spaces. Multi-row fetch moves multiple rows with a single operation, row at a time fetch, an operation for each row. On the other hand, more coding is required for applications that use multi-row fetching, unless, of course, it's a distributed program using block fetch. With block fetch, it's automatically going to use multi-row fetch as of version 8. If the program is not distributed, you do need to modify it to use arrays for processing multi-row fetch. If you look at the bottom here, depending on each particular case, number between 10 and 100 rows is a good starting point. Sweet spot may be between 100 and 1,000, and seen performance improvements as high as 50 to 60% for statements that move from single row to multi-row fetch. All right, almost near the end of the programmer-developer component, and number 10 is to keep current. This is one of the biggest things you can do as a developer, is to understand what's new, what comes with each new version of DB2. One of the biggest problems with performance and developer efficiency can be not knowing what DB2 is capable of doing. So when new versions come out, train yourself. Understand the new SQL. Understand the new functions and techniques. Look at the performance issues. Attend training. Develop coding practices based on your new features, and you will, in many cases, reduce effort and improve performance by keeping current. And that's the top 10 things for developers. Let's switch gears and move to the top 10 things that DBAs should focus on in terms of tips, techniques, and tactics. This list is more on how the job is done than actual DBA practices and procedures, but a few are going to sneak in there. At a high level, know database design theory and practices. Know what data modeling is. Know how to model data. Understand normalization and database design. You really need to know these things to develop appropriate database implementations. It's not just DDL jockeys that are needed for DBAs. You have to understand the business reason behind why the data is being created to create efficient databases. And no kludging. Use the features the way they were designed and meant to be used. When you have chronological data, use date, time, and timestamp. Don't shove them in a character column. Across the board, use the right data types for the domain of data being stored. Use multiple buffer pools. IBM's not giving you 60 buffer pools so you can cram all the data into BP0 or just a few pools. Use the flexibility of multiple buffer pools and design the data objects to go into the buffer pool tuned for the type of access that that particular object has. Use RI. Use check constraints. Let the database enforce the integrity. Don't rely on programs to do it. Your database constraints improve data integrity. One of the biggest issues I see are DBAs that push back on creating referential integrity. When you look at it, you say things like, okay, if I put RI on here, then that is going to constrain me in terms of how I operate on these sets of table spaces with utilities. But not putting RI on them doesn't change that constraint. It does change it that DB2 won't force it, but it doesn't change it that if you do it differently, you'll have integrity problems. the data still has the relationships in it, whether they are enforced by DB2 or enforced by the program. So if you say, well, I'm going to back up table A at 2 o'clock in the morning every day and table B at 7 o'clock in the evening only on Thursdays, well, you go to recover. If you don't recover to current and you try to recover to those image copies, you're going to have integrity problems because the relationships won't sync up. You'll have data in one that is trying to relate to data in the other that just isn't there. Avoid the defaults. I'm not saying this is where you'd say not null with a default. I'm saying defaults for your parameters. Understand every option that you're using, every parameter, every component. Use the one that best matches the needs of the situation and hard code that value, whether it would be the default or not. You don't want to rely on defaults because the defaults change and it gets confusing. Understand free space. Don't just let everything default to %free10 and be done with it, for example. Calculate where you need the free space and put it the appropriate amount there to give you enough room to grow in between reorgs. And if the data is static, meaning you're not changing the data or only rarely changing the data, %free0 is absolutely valid. For example, if you've got a table that has the states of the United States in it, I guarantee we'll give you time to reorganize that table space if you want when we add a state to the United States. And plan for data purging and archiving. Not all data is active, and if you don't plan to remove it, it's never going to go away, and it keep growing and growing and growing and never being accessed. So purge it when you can. When you can't, archive it. Store it away in some other archive where it isn't impacting your active data. Compression, understand compression, and it's not just for very large objects. Consider compressing table spaces as soon as they have 50 or more pages. Compression can improve application performance, giving you more rows per page, data sticking around in the buffer pool longer. Use the DSN1 comp utility. It'll tell you the type of compression gains that you might get. Compression is very efficient in DB2 for ZOS. And move to the universal table spaces. They're the future of DB2. Use range partition where you used to use classic partitioning. Use partition by growth where you used to use simple and segmented. Number 2, know the difference between importance and frequency. What's the most important thing a DBA does? Many DBAs see this question and they'll say, all right, managing performance, the most important thing I do. But they're confusing frequency with performance. Yes, DBAs confront performance issues more often than they build backup plans. And they better be managing performance more frequently than they're actually recovering their databases, or their company has big problems. But maintaining the integrity of the data in the database, including its recoverability, is at the top of the DBA task list. If you can't recover your databases after you have a problem, then who cares how fast you can access it? Anybody can deliver fast access to the wrong data, or worse yet, no data at all. That's the fastest ever, right? So it's the job of the DBA to keep the information in your company's databases secure, accessible, and accurate. If you can't do that, performance doesn't matter. Number 3, be accessible. Don't be one of those curmudgeons in the corner that are afraid, people get afraid to approach them. The more you're valued at your company for expertise and your availability to answer questions and get things done, the more valuable you're going to be. You don't want to be this guy who stands in the corner and yells, RTFM. And we all know that stands for Read the Friendly Manual, right? So, interact with the developers, walk around, learn what's going on, talk to them, share your knowledge, be viewed as helpful. Walking around, you learn what's going on. You may have some input into it and forestall problems that are coming out. You don't want to be viewed as a hermit. The other thing you want to avoid is having standards written in stone. The great thing about standards is that there's so many to choose from, right? Yes, create some DB2 standards, but realize that there are exceptions to those standards, and realize that standards over time become outdated. I see things in organizations where they have standards that say no more than 3 or 5 indexes per table. Why? That's a foolish standard. Yes, at some point you can have so many indexes that modification of data slows down, and that's troublesome, but it's not a hard and fast number, 3, 5, 7, 2. This is something where the DBAs really should be working to understand when that comes about. There's all kinds of standards that way. So avoid writing ones that have hard numbers like that, and avoid having standards where you don't allow exceptions. Also, realize you can't know everything. Instead, know where to look. It's impossible to understand everything there is to know about DB2. The Information Center online is probably the most up-to-date place to look, but the manuals can also be downloaded in PDF format. In the days back in the version 2 era where the manuals were only printed and the DBAs used to fight for the old ones when a new version came in so they'd have something at home when the phone rang, those days are over. Everyone in the organization can have access to the Information Center and can have a full set of PDF manuals on their hard drive. And know who at your company you can call for assistance, either with DB2 or with things that work with DB2. Who's the KICS expert, who's the network expert. Also, knowing where to turn and what to look for can be a hard problem for DBAs, whether you're novice or experienced. So sometimes you get confronted with that DB2 performance problem, and there's no real likely cause that's evident. So using a systematic approach can make some sense. So how does this work? Someone comes running into your office. There's a problem with DB2. So you have to figure out, okay, what's this person talking about? You ask them the question, what changed? We all know the answer to that. Nothing. So there's a problem with DB2 and nothing changed. What do we do? The good thing to do is go through the tuning progression. Start at the top. Look at the application, then the database, then the system, followed by the environment. This sequence makes sense because the majority of performance problems are caused by application code. And we look there first. Bad SQL. We look at the database second because that's the second most common cause. Third, subsystem. That's the third most common cause. So we do it in terms of common cause. But also, you might want to look at it at severity of problem. It's just the opposite order. You've got a problem in the network, it's probably impacting multiple subsystems, multiple databases. So when we look at this in terms of problem resolution, top to bottom. When we look at it in terms of severity of problem, bottom to top. So know the tuning progression, application, database, subsystem, environment, and know the order depending upon how you're looking at it. Some basic rules of thumb for the DBA, high-level things we might have heard before. The 80-20 rule, we know it because it holds, right? It holds not just in database administration and tuning, but really across the board in multiple areas. You can state it multiple ways. 80% of the results come from 20% of the effort, or 20% of your applications cause 80% of your problems, or maybe 20% of your developers are causing 80% of your problems. You can probably name the ones right now that are doing that. The bottom line there is, don't boil the ocean. Focus in on where you can get your biggest ROI. Look at the 20% that'll give you the biggest gain. Tune one thing at a time. Tuning is an iterative process. If you don't tune one thing at a time and test it, and you do a whole bunch of things at once, there's really no way to determine whether an action helped or not. So confronted with a problem, you add an index, rebind a package, add some buffer pool, and then test. Well, did one of them help? Did all of them help? Did one of them hurt and two of them help? Who knows? One thing at a time and test it out. Finally, understand what tuning is. All tuning optimizes at least one of the three things at the bottom here, CPU, I/O, or concurrency. We want to be reducing CPU usage, reducing I/Os, and increasing concurrency. If we've made a change and it doesn't do one of those three things, fine, it's a change, but it's not performance tuning. These are the three things that impact performance. Don't panic. Number 8, don't panic. Problems will occur. There's really nothing you can do to get rid of every possible problem or error. Part of your job is going to be to react to problems calmly and analytically. When a database is down and applications are unavailable, the environment you're in is going to be hectic and frazzled and people running around. And the best thing you can do when problems occur is to remain calm, go about your job, use your knowledge and training, and figure out what the issue is. I know that can be difficult to do, but the last thing that will help is running around like a chicken with your head cut off. Sometimes no action at all is what's needed. Not every problem requires a solution. For example, you've got a developer coming to your office. There's a problem with the DB2. And you say, well, all right, what are you talking about? What are you trying to do? You get down to the program. And the question is, what did you change in the program? Well, nothing that should matter. Well, in that case, I wouldn't do anything at all other than to say, take the change out and see if it works. And if it does, then it mattered. And let's talk about what the change is that you're trying to do. So in a sort of Zen-like way, do that which consists in taking no action, and order will prevail in certain circumstances. Although DBA really should be approached as a management discipline, number 9, don't fear being a jack of all trades. The DBA is often brought into projects that are not technically within the scope of database administration. The DBA is at the center of most projects and has broad technical skills and experience, so bringing them in to participate can make a lot of sense. DBAs sometimes reject this jack of all trades issue, but you really should embrace it because it helps to broaden your skill set, makes you more valuable to your company. It makes you more valuable on the job market. The more you understand, the more you know about how things work together, whether it is your core role at this point in time, the better you can be as an individual, as a DBA, and as an employee. Finally, number 10 for DBAs, be a pack rat. Write down everything, keep everything, and automate. DBAs encounter a lot of tasks and a lot of time-consuming problems. If you're wise, you're going to document the processes that were used to resolve those problems and overcome those challenges. If you have that documentation, it can be extremely valuable if you encounter the same situation again, or if someone else encounters that situation. Better to read through your notes than to try to recreate something from memory, right? And keep everything. DBA is a perfect job for you if you're a pack rat. If you keep everything you come across when you're doing your job, good for you. If you don't, it always seems like the day after you throw it out, you're really going to need it. I still have some DB2 version 2 manuals, and I keep them in a plastic container in the garage, and as long as I'm alive and can stop it, no one's going to throw them away. I've actually had some times where I've needed to go back in time to find out when and where something happened, and it's helped me on the job. And finally, automate. Why should you do it by hand if you can automate your DBA processes? Anything you can do probably can be done better by the computer if you program it to do it properly. And once you've automated, you save yourself a lot of time that you can spend better tackling other problems. As IT professionals, we're automating everyone else's job every day of the week, but a lot of times we can be averse to having our job automated. Don't be afraid of it. Embrace it. Okay, we've talked about developers. We talked about managers. I'm sorry, we talked about DBAs. Let's now talk about the top 10 things for managers that they can do regarding DB2. We're not going to spend as much time here as we did on the other lists because sometimes you just can't change managers, and also a lot of times managers aren't really sitting through iDoug presentations. But in general, the best thing you can do is be supportive and avoid cliches. I've got a couple lists here for managers to look at. Treat your programmers as individuals. Be available, but not looming. Avoid cliches. Everybody hates cliches, like work smarter, not harder, or you better work overtime on that, or this comes from upper-level management, or when I was a DBA, we did it this way, or that's no longer strategic, or you can't be out of the office that long to go to a user group. These are the kind of things we don't want to hear as technicians. We want to hear valid responses and not these cliches. Understand as a manager, you're not technically up to date like the DBA is. Know that. Don't pretend like you still are, and that's fine. That's not your job. Finally, number 10, trust but verify. So one of the things DBAs hate more than anything else is having a slacker on the team that's not pulling their own weight. So your job as a manager is to know that everyone is doing their job. So you need to trust your DBAs, but you also need to verify that they're actually capable and working appropriately. So here's that list I was telling you. If you can excise these 10 phrases from your language, I think a lot of your employees are going to be very appreciative to not hear it ever again. And with that, that's the top 10 things you need to know, whether you're a DBA, a developer, or a manager. I'd also like to point out that I've got 2 books out there for you. There's DB2 Developer's Guide, now available in its 6th edition, covering DB210 for ZOS. On my website, there is a link out there to Amazon where you can purchase that if you'd like. And also my DBA book is now available in its 2nd edition. Both of these were published last year, so they're both brand new and up to date. The DBA book is a heterogeneous book. It covers not just DB2 for Z, but also any DBA process, procedure, practice that you need to know. You can kind of use it as a roadmap for database administration. Thank you for taking the time to listen to my presentation, and we'll see you out there on the web.